Okay, so now we will be looking at graphing system of inequalities, which meaning is more than one inequality in the same Cartesian plan. So here we have two inequalities, and we will graph these two inequalities in this Cartesian plan. So how do we do that? We do that by graphing one at a time. So let's take a look at the first inequality. Here I would use the intercepts method because the y value is not readily isolated. So if what is the y-intercept if x is 0? So let's take a look at that. If x is 0, 3 times what number gives me 9? That would be, of course, 3. So I have my first y-intercept here at 0, 3. And now we are going to look at our x-intercepts. So x-intercepts, what is the x value if y is 0? So again, if y is 0, that would give me 2 times what number gives me 9? 4.5. If you can't do that in your head, half of 9 is 9 over 5, 9 over 2, or 4.5. So 4.5 would be 4 squares and half another square, for unit distance, if you wish. Now, would I do a solid line here or a dotted line? Solid line, because I have the or equal option here. That means that all the lines, all the points that are on the line will be solution. Now I need to locate the feasible region, and how do we do that? We do a test point. So let's pick 1, 1 here. Let's just pick this point here, 1, 1. So 1, 1. If x is 1, so I'll have 2 times 1, which is 2. If y is 1, I'll have 3. 3 plus 2, is that smaller than 9? 5, yes. So this is my feasible region for the first equation. Now let's do the same thing for the second equation. Here I would use the y equals mx plus b method because y is already isolated. So m, my slope, would be 6 over 1. That means I have a vertical displacement of 6 and a horizontal displacement of 1. And my slope, my y-intercept is 1. Okay, so let's do that. 1 on the y-axis, and then a vertical displacement is 6, and then 1, and then let's do another point just to be sure. Down 3, down 3 more, and then 1. So that gives me a straight line. Now here, do I use a solid line or dotted line? What do you think? A dotted line, because points that are found on the function are not solution. Now I need to pick a test point to locate the feasible region. We could use 1, 1 again. So 1, 1, is 1 greater than 6 plus 1? It is not. So all points on the left side and the right side over here are not solutions, so my solution would be here. Now my solution is the intersection of both feasible regions, so my feasible region would be found located here, right? So the intersection of both feasible regions. That's how you graph a system.